Let's take a look at the horizontal and vertical constraints in the 2D sketch environment in Autodesk Inventor. There are a few ways to use these that seem obvious, and maybe some ways that don't seem quite as obvious. We need to be sure that we cover all the bases because there's some really good things that we can do with this. If I just create a line, here is a line at an angle, no specified angle. It is not horizontal. It is not vertical. If I want this line to go horizontal, I can click on the line, come up here, click the horizontal constraint. That makes it horizontal. It also works by clicking the horizontal constraint button and then clicking on the line. Now that gives me a horizontal line. If I draw another line that is again at an angle, I can apply a vertical constraint to that one. So I have one horizontal, aligns with the x-axis, one vertical aligns with the y-axis. Notice as you draw, most of the time if you're drawing things and being careful as you go, you will get, let's zoom in a little, you will get automatic horizontal and vertical constraints. You see the little symbol that pops up there. As I get to 0 degrees, I get that horizontal symbol. As I go vertical, you might get a perpendicular constraint. You might get a vertical constraint. You see this one is giving me that perpendicular. As I go out to the left again, it is offering another perpendicular constraint. And continues with perpendicular constraints as I go. Suppose I go down here back to this endpoint because I want to close that rectangle. And now we see we have a line that is not vertical. As we discussed in the previous video, I could apply a perpendicular constraint to that, say to these two lines. I could apply a parallel constraint between these two lines, or I can apply a vertical constraint just to that one line, and it ends up giving the same result. But again, one line out here by itself, if I just select that line, hit the vertical constraint, we get vertical. The way that this will end up being useful most often, again, being sloppy, just for effect here, but if I decide one of these lines needs to be horizontal or vertical, I can fix that. I can click on one, click multiple lines, there, and that cleans it up. So it can clean up your sketch geometry, get it squared up the way that you want it to if you didn't quite get it in exactly the right orientation from the beginning. But let's work through what these two constraints actually say about themselves. If I hover over that horizontal constraint button for a second, it will show me the definition. It causes lines or ellipse axes or pairs of points to lie parallel to the x-axis. So let's see how that applies to an ellipse. Let's get rid of that sketch, start fresh, create an ellipse. That is down under the circle command. You can draw an ellipse. If I start out horizontal, see it's snapping to horizontal there. So that gets me lined up. There is that horizontal constraint on that axis. But if you draw your ellipse at an angle, you can apply horizontal or vertical. Let's click the horizontal constraint, and as I get down close to this ellipse, you can see the axis highlights. That gets the long axis of this ellipse. Tell it to be horizontal, so that gets it lined up. Now let's start fresh again with a clean sketch, and I want to show you what I think is maybe a less obvious but very useful use of these constraints. I'm going to start a new rectangle here just to have a shape to work on. Let's finish that sketch, that 4x6 rectangle, extrude that out an inch. So we're going to start adding some features to this part. I'm going to start a new sketch on the front. And suppose I want to create a series of holes across this part. Now throw some points up here, and I'm going to, again, be sloppy so that they are not lined up with each other. They're all free to move up and down. If I want all four of these points to be in line with each other, I can apply a horizontal constraint to them. First point to the second point. Let's just go back to the first point every time and apply those constraints. And now see what I get when I apply. Let's show all of them. You can see this first point has 3 horizontal constraints applied to it. Each one of these other points has 1 horizontal constraint. So that keeps all 4 of those points in a line horizontal relative to each other. I could then go on, add all the dimensions that I need to get this sketch fully constrained, and maybe put those holes through this part. Let's back up though and get rid of all those. Delete all that so I know I've got a fresh start. Let's put some more points up here. Let's go this way this time. Suppose I want a hole at each corner of this part. Let's apply a horizontal constraint this time to these 2. Apply another horizontal constraint to these 2. Apply a vertical constraint to this 2 over on the left, and another vertical constraint to these 2 over on the right. Let's fit this to my screen just so we can see everything a little better and see how these all move together. Have these 2 on the left that move together. If I move up and down, you see the one on the bottom right moves with me. And what this does now, I can apply a constraint. Let's say this is a 1/2 inch in from each corner. And when I apply all of these dimensions, because of these horizontal and vertical constraints, it makes all of these other points constrained as well. You don't have to put dimensions on every point. You just put them on the ones that you need to ensure that everything is fully constrained. So then we could finish that sketch and put some holes through that part. But let's clean this up again, get rid of what we just did, and see another way that we can use this constraint. Let's draw a circle up here. I'm just going to draw a circle out here in space a little bit. Let's apply a 1 inch dimension to that. Now let's suppose I want this circle to always be somewhere on the center of this part. Top to bottom, I want it centered. So I can apply a horizontal constraint between the center of that circle. I could come over here and pick the midpoint of this edge. I could also come over here to the origin and select that as well. And that will keep that circle, no matter what, on the x-axis, horizontal to my origin. Then all I have to do is apply a dimension to put it in place, and that keeps it constrained right there. I can then finish this sketch and maybe create an extrusion to cut that circle through the part. Now let's start another sketch on there. We'll just add some features. Now look at another way that we could use this. Suppose we want some cutouts through here. Let's throw up a little zigzag pattern here. Make sure that everything got its coincident constraints. Say I want to cut this notch out of this part, and I want to be sure that these 2 peaks always come up to the same height. I can apply a horizontal constraint between those 2 endpoints, and now they always go up and down together. Let me quickly apply some more constraints and dimensions. Just so this sketch is fully constrained. And because though we have that horizontal constraint on the top, anytime I change that dimension, that is what we're looking for, is that those 2 points always move together. I can finish that sketch and cut that feature through the part. Let's put one more sketch on this part. Create a line, an arc, and another line going up so that we have this slot that will cut out to the edge of the part. Put a couple of dimensions on it. All right, now I have this slot that is almost constrained. It says one more dimension needed. Keep in mind that doesn't necessarily have to be a dimension. I could put a dimension on here and that would fully constrain it. But what I want is to position the center point of this arc relative to this circle that is already here. So again, here I can use the horizontal constraint, click on the center point of that arc, come over here to this circle. Notice it does not pick up that circle, but I can project geometry, get that circle included. Now I can use the center point, horizontal to center point, and that will position the center of this slot here relative to some existing feature that I already had. Finish that sketch, extrude that cut, and get that cut through the part. Now let's start a new part just to do a quick recap of the main ways that we can use horizontal and vertical very quickly before we wrap up. Horizontal line or a vertical line as the simplest and most obvious way to use it. We can have an ellipse that needs to be squared up. I can apply, let's say, vertical to the short axis of this one this time, and that gets that ellipse aligned. But then the other thing is to be able to take a series of points. I can highlight all of these all at once if I want to, hit horizontal. That lines them all up, and we can see all of the horizontal constraints that were created there. Also, very useful is to take, say, some endpoints of some lines. Let's draw two vertical lines, but then say these top points of these need to stay constrained horizontal to each other. Maybe I've got some other geometry up here that I can't apply those constraints to. So that will let me, let's turn that off, that will let me keep these 2 points aligned no matter what goes on above it. Let's throw one more thing up here. Let's create a circle, and maybe this circle always needs to be aligned horizontal to the midpoint of that side. I could apply horizontal constraints to these bottoms as well. Let's apply a vertical constraint from that peak to the center of the circle, and that will position these things relative to each other, so that when one thing moves, we get this always horizontal to the midpoint of that. We get this circle always vertical from that peak up there. I hope this gives you a little more insight into horizontal and vertical constraints and some good ways to use them. If you've made it all the way to the end and this has been useful to you, a like on this video would be appreciated. If you need to get back to the constraint playlist, here is that link if you're ready for the next topic where we will look at the tangent constraint. Here is that link as well. Thanks for watching. Have a great day.